Hi, this is Mrs. Downey with your Algebra 2 Chapter 1 review. Our first problem says graph the number on a number line, and we have 15/8. Well, if we look at this, that's the same as saying 15 divided by 8, which is 8 goes into 15 one time with 7 left over. 7 what? 7/8, what we're dividing by. So if we're going to graph this on a number line, 1 and 7/8, means we're going to 1, there's 1, and now we need to go to 7/8. So it's not quite to 2. So what do? Divide that area between 1 and 2 into 8 pieces. So there's 2, 4, and there's 8 pieces. So we're going to take 7 of those. So there's 1, 2, 3, 4, 5, 6, 7. So it's right there. That is 1 and 7/8. And that's our answer. Our second problem says insert less than, greater than, or equal to make the sentence true. And they give us 4/10 and 2/6. So the first thing I want to do is just see if maybe I can get them to equal terms. So simplify. So if we simplify this, we have 2/5, and this one becomes 1/3. So 2/5 and 1/3. Okay. And if you want to divide it up into fifths and thirds and decide which is which, you're welcome to do that. It might be easier at this point just to convert it to a decimal number. So that's what I would recommend, is to use the decimal number. So 2 divided by 5, when you plug it into a calculator, 2 divided by 5 is 0.4. And 1/3, well, it's 0.33, repeating. So I'll just do a 0.3. So what is bigger, 0.3 or 0.4? So let's look at where they're at on a number line. So here's our 1, there's our 2, and we've divided these into tenths. So this is 0.4 and 0.3. So 0.4 is going to be right there, and 0.3 is right there. Which one's larger? The 0.4 is larger. So we want the arrow to point to the smaller number, or the alligator jaws to chomp on the larger number. Right? So 4/10 is greater than 2/6. So our next problem, we have to do a little distribution. And remember, when you've got a negative sign right up against a parenthesis, that's like distributing a -1 to that next term. So -1 times -3 is +3, and a -15 over here. Well, the 3 is greater, so it's going to go this way. So that is your symbol. Name the property of real numbers illustrated by the equation on number 4. Well, it looks like they started with this and they ended with this. So what did they do? They distributed this -2 to both terms to get -2x minus 4. So that shows the distributive property. Number 5 says evaluate the expression for the given values of the variables. And they give us a plus 2b. And they give us that a is equal to -5. So everywhere we see an a, we're going to replace it with the -5. And everywhere we see a b, we're going to replace it with the -2. So let me rewrite the equation with those replacements. -5 plus 2 times -2. Well, following your PEMDAS rules, this is first, so -4. So we have -5 plus -4, which is a -9. And that's your answer. Our next problem, number 6, gives us some more of the same. We're going to replace h with 3. So I'm just going to start by rewriting the original equation, and everywhere I see an h, I'm going to replace it with a 3. So I'm going to have a negative, it's like a -1 times 2, and instead of h, I'm going to put a 3 minus 4 over 2 plus h, which we say is 3. So we replaced both h's with the 3. Okay, so our next step is just to simplify. So we've got multiplication first, right? 2 times 3 is 6. And now inside the parentheses, 6 minus 4 is 2. So now up here we have negative 1 times 2 over 2 plus 3, which is 5. And this simplifies. Negative 1 times 2 is negative 2 over 5. And that is your answer, negative 2/5. Our next problem, number 7, says combine like terms. What is the simpler form of each expression? So we're just going to combine the like terms and simplify. So the first thing we need to do, though, is distribute this 3 across to this binomial. So 3 times 2y is 6y, and 3 times negative 3 is negative 9. And then we have minus 4y. Just carry that down. Alright, so now combine our like terms, 6y and negative 4y. Well, when you add those two together, you get a 2y and carry down the negative 9. And that's your answer. That's as simplified as you can get that. Our next problem is solve the equation. So this is number 8. So again, we're going to start with the distribution of negative 5y minus 10 over here. And then I'm just going to carry this down over here. Now we've got to get the y's on one side and the constants on the other. So I'm going to add 5y to get rid of that. And if I do it there, I've got to do it on this side as well. Keep things in balance. So I have 9y, and now I'm going to get rid of this 13. So that means I have to add 13, and I have to add it over here as well. So we end up with 9y equal 3. So now divide each side by 9. That cancels out, and y equals 3/9, or simplifies to 1/3. And that's our answer. Our next problem, number 9, says use an algebraic equation to solve the problem. They say a rectangle, so I'm going to go ahead and draw this as we talk. A rectangle is 5 times as long as it is wide. So we'll just let the width equal x, and then it's 5 times as long as the width. So for our length, it's going to be 5x. So we've got x and 5x for the width and the length. The perimeter is 110. Find the dimensions of the rectangle and round to the nearest tenth if necessary. So we won't round to the very end. So what we're going to do is write a perimeter of a rectangle. So perimeter is equal to 2 times the length plus 2 times the width. And we know that our perimeter, it was given that it's 110. So we're going to replace the perimeter with 110. And we know the length is 5x. So replace that with 5x. And the width is x. So replace that with x. Now let me rewrite this with my new calculations. 110 equals 2 times 5x plus 2x. Well, 2 times 5x is 10x. So we have 110 equal 10x plus 2x, which is 12x. So when we divide 10 by 12, we've got to divide 110 by 12, excuse me. We're going to get, hold on, let me pull up the calculator. Okay, so there it is. When you divide 110 by 12, you get 9.166666667. So we're going to round to the nearest tenth now. So if we round 9.16, we're going to round it up to the nearest tenth, which is 9.2. Okay? So if x is 9.2, and we said that the width is 5 times that, well, we're going to take 9.2 times 5. And we get a 46 centimeters. So the length is 9.2, excuse me, the width is 9.2, and the length is 46. There is one thing that I want to point out on this with rounding errors. It says the perimeter is 110. So really, if I have 9.2 and 9.2 and what was it, 46 and 46, because we did the rounding, it's going to cause things, we rounded up instead of rounding down, because it was 9.16, so we rounded up to 9.2. But look what happens when we round up to the nearest tenth. We end up with 110.4. So be careful about that. What we would want to do is probably just truncate that. Okay, so then we would have 110. Okay. So in a multiple choice situation, you want to look at your best answer and see which one is closest to what you've calculated. Be very careful when you're rounding. Okay, truly, you know, if they had said round to the nearest whole number, that probably would have worked out better, right? Okay, so let's move on. Okay, so number 10 says, is the following always, sometimes, or never true? And the one thing we want to do here is just solve for x and see what we get. So I'm going to move the x's to one side of the equation and the constants to the other. So first, let's combine like terms on each side. So I've got an 11 and a negative 9. So let's combine those first, and we're going to get 2 plus 10x equal, and over here we've got like terms of 14x and negative 4x, which gives us 10x plus 2. Well, I can stop right there because I see these are the same equations. This is the same as 10x plus 2, and that's 10x plus 2. So if you didn't notice that right away, you would probably say, well, let's move the 10, get rid of it. And you would notice that both of our x's disappear, and we end up with 2 equals 2. So at that point, you should have definitely noticed, oh, this is a true statement. So it's all solutions. It's always true. Okay. But as soon as you see it's the exact on each side, 10x plus 2 equals 10x plus 2, you can stop and know that's always true. For our next problem, number 11, we have the same situation. We're going to have to combine like terms on each side before we solve. So 8 minus 5 is 3, plus 5x equals 13 minus 8x is 5x plus 4. So subtract 5x from each side, and they both go away. So all my variables have disappeared. I'm going to carry down my constants. 3 equals 4. That is not a true statement, so this is never true. That's your answer. For number 12, it says solve the equation or formula for the indicated variable. So this is just a literal equation. They want us to solve this equation for u. So that means we're solving for this. When we're solving for u, it means we're going to end up with something u equals. So basically, we're just going to rearrange this to u equals and everything else over here. So let's start by writing our equation, t equal 4 over u, or 4u over e, excuse me. All right, so we're solving for u. So I'm going to circle that to remind me that stays, everything else goes. So we're going to start by getting rid of the e. So multiply each side by e. Okay, and that's like an e over 1, right? So this cancels out. And so we're left with e t equal 4u. And now we're still trying to isolate this u, so we need to divide by 4 each side. And then this cancels out. So there's our final answer. U equals ET over 4. And that's our answer. Our next problem, number 13, says, what inequality represents this sentence? So we're writing an inequality. That means it's going to have the symbols greater than or equal to, less than or equal to, or not equal. So 7 fewer than a number is at least 5. So 7 fewer than a number, we've already learned that that's going to be like x minus 7, is at least 5. So at least we represent with the greater than or equal to 5. So there it is. 7 fewer than a number is at least 5. So it means it's greater than or equal to 5. That's our answer. The next problem, number 14, says solve the inequality and graph the solution set. So we've got a k here. We're going to solve for k. Everything else needs to go away. So I am going to subtract 6 from each side. And that goes away, and I'm left with 3. K is greater than or equal to, when 12 minus 6 is 6. So now I'm going to divide each side by 3. And I'm dividing by a positive number, so I don't flip the sign. It's only when you multiply or divide each side by a negative that you flip it. So now that goes to 2. So my answer is k is greater than or equal to 2. And to graph that, we've got, let's go 0, 1, 2. So it's greater than or equal to, so close dot because it's also equal to 2, but it's greater than 2. So shade to the right. And that's it. So our next inequality, we've got some work to do. We want to distribute this 2 to both terms first. So we're going to have greater than or equal to, that's going to be a 6b minus 2. And carry this down over here, 18 plus 6b, just carrying it down. Now I'm going to get the b's on one side, so subtract 6b, subtract 6b, and you can see right away that's going to go to 0 and that's going to go to 0. And I'm left with 18 is greater than or equal to negative 2, which is a true statement. It's always true. So this is all real numbers. It's infinitely many solutions. To graph that, you're going to graph here's 0, there's positive infinity that way, and negative infinity that way. It's going to be all solutions. So you shade the whole bar and both arrows. It means anything you put in there is true. Okay. Our next equation, or next problem, number 16, says solve the problem by writing an inequality. A club decides to sell t-shirts for $15 each as a fundraiser. It cost $20 plus $9 per t-shirt to make the t-shirts. Write and solve an equation to find how many t-shirts the club needs to make and sell in order to profit at least 100. So we know, let's let the T represent the number of t-shirts they sell. And we know that they sell them for $15 each. But it costs them $20 plus $9 per t-shirt. So we want to profit at least 100. So we know that profit is equal to our sales minus our cost. So our first step is to say we want to profit at least 100. So 100 greater than or equal to, and then our t-shirts. Our t-shirt formula is going to be 15 t minus 1 times the cost, 20 plus $9 per t-shirt. Okay, so why did we subtract that? Because sales is $15 times however many shirts we sell, and our cost is $20 plus $9 per t-shirt. So 20 plus 9 times the number of t's. So the profit here, excuse me, sales here and the cost here. So now simplify. So distribute your negative sign to both 20 and 9t, and you get 15t minus 20 minus 9t. And then combine your t's, 15 and negative 9, and you're going to get that 100 is greater than or equal to 6t minus 20. All right, so add 20 to each side, and you're going to get 120 is greater than or equal to 6t. Now divide each side by 6, and you're going to get t is less than or equal to 20. So when you have to sell at least 20 t-shirts to make $100. And that's how you work that. Our next problem, 17, says if the perimeter of a rectangular picture frame must be less than 190 inches and the width is 34, what must the height, h, of the frame be? So let's just draw it. Okay, so we know the perimeter equals 190 inches. Or it must be less than 190 inches. All right. And we know the width is 34. So what is the height? H. That's what we don't know. So that's our unknown. So we do know the perimeter formula for a rectangle is P equals 2 times W plus 2 times the height. All right? So now let's replace our equal sign with our inequality. We know the perimeter must be less than 190 inches. So that means all of this must be less than 190 inches. So 190, all of this, the 2 times the W plus the 2 times the H, must be less than 190 inches. Well, we know the width is 34, so replace W with 34. But we don't know the height, so we're going to leave H alone. So now let's simplify. 190 must be greater than, that's going to be a 68 plus 2H. Now subtract 68 from each side, and you're going to get that 2H is less than 122. And now divide each side by 2, and you get that H is less than 61 inches. So the height must be less than 61 inches. And we could reverse that like that. There you go. That's our answer. So remember, if you reverse the side that your variable's on, you've got to flip the sign with it. So if it's pointing at the H, then when you flip it, it still has to be pointing at the H. Okay? Okay, so is the inequality sometimes, always, or never true? So we're first going to distribute this -4 before we start solving. So that's going to be a negative 8x minus 32 is greater than negative 8x plus 8. So I'm going to get rid of this 8x. And I notice right away that's going to go away, and so will this. And I'm left with negative 32 is greater than 8, which is a false statement. So this is never true. And that's our answer, never. Our next problem says solve the compound inequality and graph the solution. Now we've got an and, so we're going to solve both of these individually, okay? So we've got 7x plus 2 is greater than or equal to negative 33, and I'm just copying that. So I'm just going to solve this side first. So subtract 2 from each side, and I get 7x is greater than or equal to negative 35. Now divide each side by 7, and I'm going to get x is greater than or equal to negative 5. So there's my first part. Now I've got the and, so don't forget that. Now let's solve this side. 9x minus 9 is less than or equal to negative 36. So add 9 to each side, and you're going to get that 9x is less than or equal to negative 27. Now divide each side by 9, and you're going to get that x is less than or equal to negative 3. So there's my two statements. Now we can combine that in one statement, right? So that would be a negative 5, and it's pointing at the negative 5, right? So it's got to be pointing at the negative 5 still. X, and x is less than or equal to negative 3. How do you graph that? So negative 5, negative 4, negative 3. So they're both closed. So it's x is greater than negative 5, but it's less than negative 3. So it's a segment. Remember, and makes the segment. And that's your answer. The answer in the graph. The next one, we have an or. Remember, or makes the gap. I say a gorp because or makes the gap. Right? So let's solve. So we've got 4x minus 6 is less than 2. So add 6 to each side. And you get 4x is less than 8. And divide each side by 4, and you get that x is less than 2. So there's one of them. On this side, we've got an or in the middle, or, and we've got 4x plus 2 is greater than 14. So subtract 2 from each side, and you get a 12. So we have 4x is greater than 12. Divide each side by 4, and you get that x is greater than 3. So there's my two equations, or excuse me, my two inequalities. And now we're going to graph it. So on a number line, we've got a 2, 3, okay, and we'll just do a 1 there and a 4 over here. So we've got less than, x is less than 2, not equal to, just less than. So it's an open hole, and less than, so it shades to the left. And it's greater than 3, not equal to 3, so it's an open hole, and it's greater than, so shade to the right. See, and there's your gap in between. So there's your or statement. Okay, erase that one. Okay, and that's your answer. All of this. Okay, our next one, now we've got a 3-piece inequality. All right, so we have to solve for this variable x. So I'm going to start by writing the equation. Negative 12 is less than or equal to 2x minus 4 is less than 10. Okay, so I'm solving for x. So I've got 3 pieces here. So you still solve it, but what you do to one, you have to do to all 3 pieces. So I want to get rid of the 4. So add 4, I have to add 4 there, and I have to add 4 here. This goes away. So we have 2x less than 14. We've got a less than or equal to, it's going to be a negative 8. All right, so now we're still isolating this x, so we have to divide by 2, and divide by 2, and divide by 2. So we get a negative 4 less than or equal to x less than 7. There's your answer. So how do we graph that? Well, draw your boundaries. There's a negative 4 and a 7 out here, and 0 would be somewhere in between. So on this negative 4, we're going to say that x is greater than or equal to negative 4. So it's a closed circle, and it's greater than or equal to, so we're going to shade to the right. But x is also less than 7. Not equal to, but just less than. So open hole on 7 and fill to the left. And there's your graph. This is your answer. 22 says solve the absolute value equation, graph the solution. So the first thing you want to do is isolate your absolute value, and they've already done that. It's isolated. So now to remove those bars, the absolute value symbols, we have to solve this two ways. We have to solve this as a positive one, and we have to solve it as a negative one. Okay? So when we do that, let's just solve the left side first. So add 3 to each side. And you get that 2x equals 4. Divide each side by 2. And you get that x equals 2. So there's part of our answer. All right? And then on the other side, add 3 to each side. And you get 2x equal 2. Divide each side by 2, and you get x equal 1. So there's our two answers. And to graph those, they're just single points at 0, 1, 2. So it's going to be at 2. There's x equal 2, and here's x equal 1. So they're both closed dots on those points. And because they're only equal signs, we don't do any other shading. And that's your answer. Number 23, we've got 2 times the absolute value of 4x plus 1 minus 5 equal 1. So the first thing we want to do, we've got to isolate this absolute value inequality, or its absolute value. So the first thing we want to do is add 5 to each side. That goes away, and this goes to 6. So we have 2 times the absolute value of 4x plus 1 is equal to 6. Now, we're going to divide each side by 2 to get rid of that 2. Now we've isolated that absolute value, 4x plus 1, okay, equals, and 6 divided by 2 is 3. So now we've isolated that. Now, to remove it, we're going to solve it as a positive 3 and a negative 3. So 4x plus 1 equal a positive 3, and 4x plus 1 equal negative 3. Now solve each side. So subtract 1, and you get 4x equal 2. Divide each side by 4, and you get x equal 2 divided by 4, which is 1/2. Okay, and then over here, subtract 1 from each side, and you get 4x equal negative 4. So divide each side by 4, and you get x equal negative 1. So there we have it, x equal 1/2 and negative 1. So how do you graph that? So here's 0, 1, 2. Okay, and here's our half points. Okay, so we've got x equal 1/2. So that's going to be here. And x equal negative 1 is going to be back here at negative 1. Okay. And my spacing is a little off, but that's at a negative 1 and a 1/2. Okay, and that's it. Okay, so the next one says solve the equation, check for extraneous solutions. So the first thing we're going to do is solve. So we want to, okay, the next problem says solve the equation, check for extraneous solutions. So we have 3 times absolute value of 7 minus 4x equal 4x plus 3. So the first thing we want to do is get rid of this 3. We've got to isolate the absolute value so we can solve it as both the positive and the negative. So divide each side by 3. When you do this, this is going to be cancel out. So you get absolute value of 7 minus 4x, absolute value, equal, and I'm going to put it in parentheses now, 4x plus 3 over 3. All right, now to solve this as the positive and negative, we're going to go 7 minus 4x equal the positive 4x plus 3 over 3, and we're going to solve it as the negative 7 minus 4x equal, I'm going to put it in parentheses, negative 4x plus 3 over 3. So let's solve the right side first. So the first thing I'm going to do is we've got to solve for x, but we've got to clear this 3. So I'll multiply both sides by 3. Okay, and those cancel out. So over here I'm going to have 21 minus 12x, distributing that 3, equals 4x plus 3. Now the next step is to combine the x's. So I'm going to subtract 4x from each side, and I'm going to add, or excuse me, subtract 21. Let's subtract 21 from each side. So I end up with negative 16x equal negative 18. Well, now multiply each side by negative 1, and we get rid of our negatives. So now divide each side by 16, and you get that x equals 18/16, or divide each one by 2, and you get 9/8. 9/8 is just 1 and 1/8. So there's your first answer, 1 and 1/8. Now let's get the second side. So I'm going to clear this negative sign first. Multiply both sides by negative 1. And when we do, this whole thing gets multiplied, and then that one goes away. So it becomes negative 7 plus 4x equal 4x plus 3 over 3. Now multiply both sides by 3. Right, and then this clears, and we have, whoops, didn't mean to do that. Okay. Then we have negative 21 plus 12x equal 4x plus 3. Subtract 4x from each side, and you get 8x. Add 21 to each side, and you get 24. So 8, divide each side by 8, and you get that x equals 3. So there's my two answers. X equals 1 and 1/8, or x equals 3. So now we have to figure out if they're extraneous solutions, we have to plug both those answers back into this equation and see if it's true or false. So I'm going to erase this, 1 and 1/8 and 3, 1 and 1/8 and 3. So let's check 1 and 1/8 first. So when you plug that in and you check it, you can also do it by 9/8 and just plug it in for x, and you'll find that yes, it does check. So 1 and 1/8 is true, not an extraneous solution. And then when you plug in 3, which we can do quickly without a calculator, we get 3 times the absolute value of 7 minus 4 times 3 equal 4 times 3 plus 3. 4 times 3 is 12. 12 plus 3 is 15. And over here, 4 times 3 is 12. So 7 minus 12 is negative 5. Absolute value of negative 5 is 5. And 3 times 5 is 15. 15 equals 15. So this checks out also. Neither are extraneous solutions. So they both check out. And that's our answer. 1 1/8 and 3, and neither are extraneous. So 25 says solve the inequality and graph the solution. So this is already isolated. So now we're going to solve it both ways. So we're going to have take away the absolute value symbol. So 4x plus 8 is less. Remember, actually let's solve it the opposite first. If we're going to go the negative 16, then we have to flip the sign. So flip the sign, negative 16. Okay, now the other one, it stays the same. 4x plus 8 less than or equal to 16. So the positive of that number is always right, but when you do the opposite of that number, you always flip the sign. Okay? Now solve each side. So add or subtract 8 to each side, and you're going to get a negative 24. And now 4x is greater than. Now divide each side by 4, and you get that x is greater than or equal to negative 6. So there's one side. Now the other side, subtract 8 from each side, and you get 8. Then divide each side by 4, and you're going to get x is less than or equal to 2. So there's our answers. So to graph that, we're going to have a negative 6 over here and a 2 up here, and 0 would be in between. So it's greater than or equal to negative 6. So because it's equal to, close the dot and shade to the right because it's greater than. Less than or equal to 2, close the dot on 2 and shade to the right. So it's a segment between -6 and 2 inclusive. And that's your answer. So for 26, we're going to do the same. So now we've got an absolute value and greater than. So we know that greater than is going to make the gap, the or, the less than makes the and, the segment. So now we're going to go 7x plus 7 is greater than, whoops, let's flip it first. I try to do things the same way. So to do the negative or the opposite, you've got to flip the sign. -21, and then you're going to do 7x plus 7 is greater than 21 and solve both ways. So subtract 7 from each side and you get -28 is greater than 7x. Divide each side by 7 and you get x is less than -4. Over here, subtract 7 from each side and you're going to get a 14, and then 7x is greater than 14. Divide each side by 7 and you get x is greater than 2. So there's our two answers. Now to graph it, let's do our boundaries. Here's -4 and here's 2 up here with 0 in between. So x is greater than 2. So open hole on 2 and shade to the right. But it's less than -4, so open hole on -4 and shade to the left. Remember, the greater than makes the gap, the less than makes the segment. That's our answer. So 27 says, when spheres are as ship's bags of golf balls, the number of balls in each bag must be within 8 balls of 150. So if I've got 150 here, and it's got to be within 8 balls of 150 balls, that means it could be 8 more at 158, or it could be 8 less at 142, and inclusive. So it's got to be, it could be any of this, right? And then that makes it the middle point, with this being 8 more and this being 8 less. Okay, so how do we write that as an inequality? Well, it means if I'm going to let B represent my number of balls, it means that that 150 is that B, right? So we have to be less than or equal to 158 or greater than or equal to 142. So there's your inequality. So to represent this as an absolute value equation, it means we're dealing with 150 balls, but we could have an error here, right? But the error margin must be less than or equal to 8. So 150, the absolute value of 150 minus the balls, however many we have, could be up to 158, but less than 100 or greater than 142, must be within that error range of 8. So that's how you represent the inequality. And that, guys, is our test. And thank you for watching. This concludes our review. Study well, and your test is tomorrow. Thank you.